All right, so Unit 2, Day 2, we're going to look at inverse functions, which we've all seen before. So this should be pretty much a day of review. And then we'll take inverse functions to the next level at some point this semester. All right, so today's key idea is every function has an inverse, but not every inverse is a function. So for example, if I was to give you x and f of x. If I was to give you 1, 2, 3, 4, and 5, 6, 5, 6. Okay, so this would be that every inverse or every function has an inverse because my original f of x is an inverse because each x is only paired with one y value. But if I was to reverse this and change my f of x and my x, which is what happens in a inverse function, I would have 5, 1, 6, 2, 5, 3, and 6, 4, which makes the inverse not a function because the value of 5 has two different values and 6 has two different values. That's the idea that every function has an inverse, but this inverse would not be a function. So the general idea of an inverse is if I have an original value, maybe f of 2 is equal to negative 17. So that would be my original. For my inverse would be f of negative 17 equals 2. So here my x and y switch places, input, output, switch places. Or if you look at domain and range, they switch places. Okay, so that's the general idea of an inverse. Okay, so looking at an inverse on a graph. Okay, so a function and its inverse are symmetric or reflected over the line y equals x. Okay, so if I sketch my line y equals x here, so there's my line y equals x. If I sketch an original function for you, maybe if I put 0, negative 3, 1, negative 1, and we'll go 1, 2, 3, 4, 0. Okay, so there is the graph of a function. Here's 0, negative 3, 1, negative 1, and 4, 0. If I'm going to graph the inverse, I'll call this f of x. If I'm going to graph the inverse, then all of those x and y values are going to switch. So I'm going to have negative 3, 0. I'll have negative 1, 1. And I will have 0, 4. So when I sketch this function, you can see that it is completely reflected over that line y equals x. So the notation for an inverse looks like a negative 1, but it's called f inverse of x, or the inverse of f of x. So x and y switched places, a complete reflection over the line y equals x. Both of those would be a function. Okay, so to find the algebraic inverse, if it's written as f of x, you're going to write it as y equals. What you're going to do is switch your x and y. Take the equation or the function, solve for y. And the fourth step is to finalize it. You're going to write in inverse form. We change the y to f inverse of x. Let me write that for you. So inverse form is f inverse of x instead of y. All right, so we're going to practice a few of these. Okay, so we're going to find the inverse. So first step, write it as y equals. We're going to test your algebraic skills. Second step, we're going to switch our x and y. Lastly, we're going to solve for y. So here I need to multiply both sides by 3. So 3x equals 5 minus 12y. Subtract your 5. And divide both sides by negative 12. So I can have 3x minus 5 over negative 12 equals y. So I can have a few different forms of this. I could have f inverse of x equals, and I can put the negative sign even. Which is probably the best way to do it. Or you can actually simplify and separate that denominator. So if I go back up here, I would have 3x over negative 12 minus 5 over negative 12. So f inverse of x would equal negative x over 4 plus 5/12. So either one of these would be acceptable. Probably this is your best bet. That way you don't mess up on separating that with your positives and negatives. All right, so that was a basic linear one. We started off linear and we ended up with linear. Okay, so now we're going to do a little more complicated one, a cube root. So first thing we're going to do is write it as y equals. Make sure you keep that fraction bar nice and long. We're going to switch our x and y. And we're going to solve this for y. So multiply both sides by 18, by 18. We need to cube both sides to get rid of that cube root. So on the left side, if you get your calculator and take 18 cubed, you're going to get a pretty large number that is 5832. X cubed equals y minus 9. Add 9 to both sides. And go ahead and change the y to inverse notation. So we should know from our World of Algebra 2 and or college algebra that the inverse of a cube root has to be a cubic function because they undo each other. Okay, so dealing with rational exponents. So I have x minus 13 to the 2/5 minus 8. I'm going to switch my x and y. So x equals y minus 13 to the 2/5 minus 8. I'm going to add 8 to both sides. And then from our world of algebra, we may or may not remember, but to undo that power of 2/5, we're going to take both sides to the 5/2. So the reciprocal of 2/5 is 5/2. That makes the right side y to the 13th to the first power now. So I have x plus 8 to the 5/2 equals y minus 13. So if I add 13 to both sides, I have x plus 8 to the 5/2 plus 13 equals f inverse of x. Okay, so remember that power of 5/2 is the same as the square root of x plus 8 to the 5th, but it's just as simple to leave it to the 5/2 power. Okay, so there's a few with one with rational exponents and one with the cube root. So now we're going to do a rational, which sometimes get a little more complicated. So I have y equals 3x minus 5 over 2x plus 1. Switch my x and y. And perform some algebraic magic. So I'm going to multiply both sides by 2y plus 1. Keep your parentheses there because you're multiplying by an expression. So now if I distribute my x, I have 2xy plus x equals 3y minus 5. So now in order to solve for y, you have to get all of your terms with a y on one side and all of your other terms without a y on the other side of the equal sign. So I'm going to move my 3y over to the left, and I'm going to move my x to the right. So I'm going to subtract 3y, and I'm going to subtract x. So here these cancel. This cancels. So I'm left with 2xy minus 3y equals negative 5 minus x. Now to get y by itself, I'm going to have to factor out y as my greatest common factor. And divide both sides by 2x minus 3. So I get f inverse of x, because that'll get my y by itself, equals negative 5 minus x over 2x plus 2x minus 3. Or maybe a better form. That form's fine, but you could factor out a negative on the top and have 5 plus x or x plus 5 over 2x minus 3. That eliminates quite a bit of negative signs or subtraction signs. Okay, so the inverse of that original rational function was a rational function. So it's kind of like if you have a rational function that looks like this, the inverse is going to look like this, perhaps. Perhaps, not necessarily that one that we just did. All right. So now looking at one-to-one functions graphically. Okay, so a one-to-one function is a function where every element of the range or the output is related to exactly one element of the domain. So I kind of started with this when we started talking about that very first page of these notes where I gave you the T-chart with values. Okay, so if I have a domain and a range. So if I have 2, 3, 4, 5, and I have 12, 3, negative 7, 11, so this would be a one-to-one because my range values don't repeat. So this is a one-to-one. An example of one that's not a one-to-one . So 2, 3, 4, 5. Let's just go 7, 7, 8, 2. Okay, so it is a function because every element of my domain is matched with exactly one value of the range. But when I go this way, I can see that the value of 7 is matched with 2 different input values, which makes it not a one-to-one. When you have functions that are one-to-one, then the original function and its inverse are both functions. When you have a non-one-to-one function, then the inverse of the original is not going to be a function. So when looking at graphs, if you remember the original, when we looked at the original graph, the vertical line test told us whether it was a function or not. When you have the original function f of x, if you use the horizontal line test, if it passes the horizontal line test, then the inverse is a function. But if it fails the horizontal line test, the inverse is not a function. This first one here, this polynomial that's graphed, that's a function because it passes the vertical line test. But when I place a horizontal line at numerous places on this graph, it fails the horizontal line test. This would not be a function, or the inverse would not be a function. Not a function. It fails the HLT. So for this one, I can place some horizontal lines here. Now it looks like it fails it right in here, but it's just that is so close to the x-axis that it appears to be a horizontal line itself. You can see why, because that y-axis is so large and they have intervals of 100, so it appears that it's really close. But you can see that it passes the horizontal line test. So it is a one-to-one. And the inverse would be a function. So if you spread this out a little bit, just to make it look, it's probably looking more like this. Cube root function, reflected cube root function. All right, so those notes were fairly short today. Everybody have a great day.